hope you are all doing fantastic today on this October 2nd. Today is a Sunday, so we are live at 4 p.m. Eastern today because I just wanted to make sure that the normally scheduled live streams were at the same time. But because we are in October, we are celebrating our first and possibly annual, depending on how well things go, Invertober. Alright, so something that I love is that we can talk about invertebrates, but I threw that K back there because over the course of October, we're also going to be going over some of the pencil drawings that we have done this year, and I'm going to be finalizing them with my pen, so that as we continue to move forward and build all of these awesome sketches, we can continue. I can, do the things. Yay for Invertober! All right, very good. Mondays, we are going to be doing animal meet and greets. I'm going to call them Monday meet and greets. And there are 4 Mondays in October, so I figured we would do one on tarantulas, one on scorpions. I thought that we would go upstairs and you could meet my chinchillas. Their names are Zila and Lulu. And then I was going back and forth because we could do another class on the other inverts that I have. I've got a handful of beetles and things. Or you could be introduced to my cats because I thought that could be fun. We might do that. So, yay! Welcome, Avea. I'm glad you're here hanging out with us today. For all of the rest of you out there who are hanging out with us today, you can go ahead and drop a chat if you would like. So if you have seen this graphic on Facebook, you can go ahead and share it. That's always super, super appreciated. Today, kind of share the love. And I was just in the process. I haven't finished getting the events onto the John Law's calendar, but that will be completed right after this live stream. So all of the events for Invertober is going to be on the John Muir Law's calendar, and I will have the different events, like what the plan is for that day, labeled in the calendar, so you know what's up. Yay! Yes! So I thought that we would sketch Tabanity, and for those of you who don't know what that is, it would be, there it is, come on, there it is, a horsefly. Alright, so we are looking at a fairly large black horsefly. I want to get, yeah, there we go. Now it's all lined up. Okay, so this is, yes, a fairly large black horsefly. I couldn't imagine being bit by a horsefly like this, and we are going to be able to flip our specimen over, and then we'll be able to see what their actual mouth parts look like, so that you can kind of see kind of how horseflies do bite you. This is our specimen on the table. Aha. My ruler likes to, oh yeah, my ruler is green, so it makes me disappear. I forget about that. Oh, man. So, if we are looking to measure this horsefly, I was kind of excited about it because it was so large. I picked it up. It doesn't have an ID label yet because I picked it up this summer, and I haven't printed any of my labels for this summer yet. So this was collected in June at, on Mount Misery, on a trail called Mount Misery. So that's kind of great. Now, we're going to go ahead and measure our friend here from the front of the head, and I'm going to stop at the back of the abdomen rather than the back of the wings. I'm going to say we are at approximately 2.5 centimeters. So 2.5 centimeters for our specimen here. All right. Yeah, and the head is all eyes. All right. There is nowhere on its head really that doesn't have eyes. And if we really zoom in on them, the individual cells are really kind of beautiful. So when we're looking at a compound eyes like this, all of those individual lenses in the compound eyes, they're called Omatidia. And that's the plural version of the word Omatidium if you were talking about one of those single lenses on the eye. Now, if I get Terry out here and we point him over in this direction, that little V there, that's the head portion that doesn't have eyes on it. So it's pretty much all compound eyes. Now, I thought we would also kind of look at this fly head on. So as we can see, oh, that's super cool. Check that out. Look at that. The Omatidia on the bottom side of the compound eyes are a different size than the Omatidia on the top of the compound eyes. I don't have an explanation for you because I'm not sure why. But you can see the very distinct line in between the Omatidia that are larger and the Omatidia that are more fine. I would assume that with eyes that are more fine or more eyes in the space, that the image would be clearer. I wonder if the compound eyes are more fine on the bottom side of the eye because maybe the fly, as it's kind of, they're going to be flying all over the place, right? And they are looking for, they're looking for humans to bite. No, but they are also looking for other mammals and things, reptiles, to drink their, to bite. So maybe those Omatidia on the bottom side of the compound eye are more focused or are more adapted to seeing down towards the ground, whereas these ones up here can see forward. I think that wave is really cool, though. Yeah, that's really awesome. All right, so the other thing that we are looking at here is this split in the eyes, right? So our compound eyes split right down here in the middle, and then you do have a little bit more head. You've got the antenna, and then this stalk that's coming down, that's actually our mouth part. So let me go ahead and scooch our specimen just a little bit, and we're going to be able to see this mouth part. Ooh. All right, so this mouth part is 2 pieces. And I admittedly, this specimen is brand new to me, so I hadn't put this specimen under the microscope until we put it under the microscope on Thursday, really quickly when we were talking about compound eyes, and then I thought, we definitely need to look at it again. Look at this mouth part. So, right about here, let's see, I want to get it more in focus. There we go. That's better. All right, so this part right here, as you can imagine, is the stabby stab part. So our horsefly is going to be drinking the blood of its prey or its hosts, right? So when a horsefly comes and lands on you and wants to, they say bite, right? When they want to bite you. But horseflies don't actually bite because they don't have chewing mouth parts, right? So to be able to bite somebody, you need to go, ah. Right? You need to actually bite them. Whereas horseflies, they don't chew. They have a little knife-like part. And this mouth part right here, it goes in and it kind of stabs the prey. All right? It stabs the host. And then once the blood starts coming out of the skin or outside of the whatever membrane they've punctured, this section right here is kind of like a giant sponge. So a lot of fly digestion is actually happening outside of the body. The digestion for the flies start outside of the body, because a lot of them will also spit on their food and use that to soak it up. Exactly. So next time someone gets bit by a horsefly and they say, I got bit by a horsefly, say, no, you got stabbed by a horsefly. And I figured horseflies are, kind of spooky, so appropriate for October. I'm going to turn our mouth part sideways so you can see the sponge-like side part from the side. I think that this will be, yes, there you go. All right, so as you can imagine, this stalk is just kind of, this is the stalk to the sponge, or almost like what you would consider like a handle. It's the part where it comes out of the head and it goes down. This part here is kind of circular, and it has all of those hairs on the bottom of it. And those hairs are going to help with uptake. And then this whole bottom here it acts as a sponge, and it soaks up the blood through here, and then it gets drank, and it goes into your horsefly's digestive tract. Maybe one day we will go over all of the parts of insect digestion. Insects actually, people say insects have 3 stomachs because they have a foregut, a midgut, and a hindgut. But it's just that they have a very different form of digestion than we do. Now, this is a, well, you'll know that it's black because you can see that. But the common name of this horsefly is the black horsefly. And now, I have not put this insect individually through a key yet because it doesn't even have a label yet. But I believe that this is the black horsefly Tabanus atratus. Alrighty. So, if we're starting up here at the tops of our paper, I'm going to write the black horsefly. And it is important that the word horse and the word fly are 2 separate words. Horsefly is not one word because horseflies are a true fly. Right? They only have 2 wings. They do have they have halteres as their modified hind wings. They're a true fly, which means they're 2 words. And our scientific name is Tabanus a trotis. Perfection. All right, moving on back, I want to make sure that we get the overall sketch, our overall light sketch of our horsefly figured out. So, you can see, I guess it's pretty obvious that our horsefly's head is very D-shaped, right? It's flat on the bottom, and it's very rounded on the top, and it's all eyes. So last night, because it was October 1st, and I was really wanting to get one live stream done every day of October, so I did end up live streaming last night really quickly. We did 2 line drawings. We did we did the antlion put into ink, and then we also did the thinid, the flower wasp. We did that one in ink. This is how the flower wasp came out. I was pretty excited about it. So pretty. Okay. So we've got our horsefly head taken care of. I'm going to go ahead and scooch our specimen back just a little bit so we can see a better view of the thoracic region. He's so dark, he might be a little bit more difficult to see characteristics on, but I also figured he was a good insect to start our Halloween month on. Thank you, Avea. Alright, so something that people... Haha, Darth Vader. You could almost hear him going... So, let's... I'm not happy. I'm going to move our specimen down just a little bit. I want to see the width of the head in comparison to the thorax. So I wanted to see a little bit more of the head before I started sketching. He keeps his lightsaber in his mouth! Yes! Stabby stab! So there's something quite interesting about our friend Darth Vader here. If you look at his head does not connect to his thorax completely. In fact, if I was to bump his head and accidentally knock it off, it's actually sitting kind of on a stalk. And so fly heads fall off really easily, and that's because inside of here, the inside of the head is kind of like this concave section, and then when you're looking at the thorax just has kind of this peg like this that goes into the head and just holds on right at this one point. And that gives the head a lot of movement and the ability to kind of turn and wave. And so, not wave, but kind of like to turn and to kind of further manipulate their heads. So when we're sketching these guys, we're not going to connect the edges of the head to the thorax. We're more like going to kind of imagine that there was a peg kind of sticking out from the center, and you're just gonna make sure that the edges don't touch. All right. Our thorax, let's see. I would call this piece here along the top our pronotum, so we can see that there's this little suture or this line in between the exoskeleton pieces right here that kind of comes up and then does a little wave, and it's going to go down at the same angle that this one comes up on the other side. So if we were to kind of start it like this, then our pronotum... And this is our light sketch, right? So we're going to be coming back. Sometimes I have to remind myself of that. And we want this part to come down at an angle, like this. And, funny enough, whatever angle this piece comes in at, you also have your wings. And these wings both go straight out from this point, and they come in and they meet at the center here. So they're going to follow this angle. And they're going to come in and kind of meet here at the center. And let's scooch our specimen back and see what our wings look like a little bit. All right, so our wings are going a little bit past our abdomen. Let's see. I'm going to leave that here and bring our specimen over because I want to see the overall kind of shape here. So I have a boo-boo. I was washing the dishes and I put my hand into a glass and the top of the glass broke while my hand was inside of it and it sliced my pinky. And of course it was my left hand because my left hand is dominant, and so my lines may not be as smooth today. We're trying really hard. So, this is what I'm coming up with. Our wings are, for our light sketch on our wings, they're going to come out right about here at this angle. Where this angle starts, that's where our wings start coming out. And they're going to come out in to make this kind of like a triangular pattern like this. It reminds me a little bit of a plane. Not sure why. So make sure that those angles, they come out kind of at the same angle. And then once these wings meet in the center, they meet in the center for a moment, and then they're going to angle away from each other to give us this shape here. I know. Boo-boos are rough. And it's like, you know, right there on the edge of my pinky. So, you know, as a left-handed person, you're always dragging your hand along the graphite and stuff as you're writing or sketching. And so I just didn't go and put a Band-Aid on for class. It'll be fine. It'll be fine. All right. Now, let's see. I think I'm pretty happy with that overall light sketch. I do want to come in and, let's see, estimate the abdomen. So the abdomen is going to be, let's see, I'm going to guess. That looks about right. And now I'm not going to add the segmentation until we zoom in and we get back to that. But that gives us, oh yes, that gives us an overall kind of super light sketch of the overall body shape. We know that the wings are going to stay on the paper. That's going to be important because the key characteristic for all horseflies and deerflies is found on the edge of the wings. So we do want to make sure that the edges of the wings stay on the paper for when I show you what the character is. Oh no! A wild rose high-fived you in the eyeball? That sounds like it would hurt a lot. Was it a native rose or was it a multiflora rose? Because if it was the invasive, the multiflora rose, you could pull it out. Or the non-native. I'm not sure if it's particularly invasive. Oh, you do love it. Okay, good, it's a native. Then you can be super happy about it. And it's like, sometimes I'll even name plants, that I love. All right. So, giving additional details to our head and our antenna, we've seen a lot of the head. We did focus a lot on that in the very beginning. Oh, look at how pretty it is. When it comes into focus, I just love it. But I wanted to kind of focus down a little bit so we can see what the antenna look like from a dorsal view. Now, I'm going to admit, I'm not sure what you would call these antennae, because they don't look like, normally flies have aristate antenna, or like the sausage shape with the individual hair. These are a little bit stronger, and they've got that spine in the middle of the antenna. I'm not sure what you would call these. Oh, good. I'm glad that you're cheering the rose on and that it's fighting for its life against that silly ivy. Oh, man. Ivy can really strangle plants. So I'm working over, I did pick up a position at a local nature center in Pennsylvania. And it's called Silver Lake Nature Center. And they've been working on pulling, we have Japanese stilt grass up the wazoo, and that, as you know, is invasive. And so we've been trying to get rid of that. All right, so I am rounding the corners of my eyes here because they were just too strict. They were too harsh. We did see this a little earlier, this little itty bitty triangle down here. That's kind of in between those eyes. I'm coming back in and I'm kind of darkening the lines that I'm happy with and modifying slightly the lines that I feel need it as I've now zoomed in. Coming back in this direction, there's also this kind of triangle here because that is where the antennae are going to be coming out. That's our head right here. Or this section right here, that's a little bit of the head, whereas all the rest of this is eyes. So moving forward from here, let's go ahead and just zoom in on those antennae. Okay, yep. That's what I thought. Alright, so it looks like these antennae are 3-segmented. So there are 2 segments that make up the base, there and there, and then this 3rd segment is the one that has this spine, and honestly, their antennae look like blades too. So we're coming in here, and we are adding the 2 segments at the base. These segments, they do have bristles and hairs on them, so if you wanted, you could kind of go ahead and make those a little fluffier. And then our 3rd segment comes out like this. It's got this this spine on the inside, and then it has the longer piece here. I think you would still call these antennae with the same segment names. So the first one would be the scape. The second one would be the pedicel. And then I would assume that this third segment here would be the flagellum. Although there's only one segment, and normally flagellum are multi-segmented sections of the antenna. Alrighty. So let's see. Get this a little dark. Alright, and then inside of our compound eyes, I always like to crosshatch, but these eyes are so large. I'm going to make my crosshatching just a little bit wider, although we know that there are many, many segments in here. Now, it would be interesting to draw the head from the side so that we could see the differentiation between the larger Omatidia and the smaller Omatidia, or the individual cells in the eyes. He's so shiny, he's reflecting my light. I don't know if that light is doing much for him. Maybe it is brightening his dark side. He has a dark side because he's Darth Maul or Darth Vader. Alright, so coming back in, we've got our head taken care of. We're going to be doing the thorax now. I'm pretty happy with this shape here, how I connected my head to my thorax, but I do need to work on this line here, because it's not just this natural arch. I drew that just to kind of remind myself to sketch it. But coming up from the side, they do have these kind of very stronger angles. And then, so on both sides. And you can use the wing kind of as a starter point. So I'm actually going to move this one a little bit down. Sometimes I like to give myself guidelines, especially when I'm working in flies, because with flies, I'm not as naturally inclined to sketch them. So trying to make sure that I keep my center line central. He is so floofy. Yes. And those floofs, the individual insect hairs, are called CT, and the word floofy, if you want to say it in a scientific way, we can say he's so cetos. That's our word for floofy. Cetos means fluffy, insect fluff. All right, when we get up to the top of these angles, it's going to kind of come down. The lowest point is going to be at this central line, and then it's going to come back up again. And we want that to stay as even as possible. Yes, cetos. I think the right got higher higher than the left somehow. Yeah. Something like that. I feel like maybe if I pull this up a little bit. Yeah, that's better. Okay, that's what was wrong. I just needed to pull this angle up just a little bit. Okay. All right, moving down from, this is what I would call the pronotum, the first section of the thorax. This segment here, admittedly, flies have very complicated anatomy. This section right here, though, would be the second segment of the thorax. Ooh, and check that out. We can even see the third segment. All right. So the second segment is this section here. It's fairly large and roundy. This second section of the thorax is where you also want to put your pin in. So that's what that little gold thing in the bar is that goes into the insect. That's the pin. And then if you look at the very end of this here, you can see that there's this other suture or a connection between two pieces of exoskeleton. That right there is the third segment of the thorax. Or... yeah, that's another segment on the top. I believe, yes. All right, so, ladies and gentlemen, you know how this isn't, it's not technically, it is part of the thorax, all right? And you know how in beetles, there's the little triangle that's in between the elytra, and we call that the scutellum? In flies, this little triangle down here on the bottom of our thorax, that's what's considered our scutellum. So if we wanted a couple of new scientific terms, this segment right here, this suture right here across the top, people call this in flies, we call this the transverse. We call it the transverse suture. And that's this one up here, that's this wavy line that we sketched. That's going to be our transverse suture. And then down here on this angle, that is what we're going to call the scutellum. It's really going to be right there. Let's go ahead and finish up this back so that we can add it to our sketch. So I'm going to give a little indentation, kind of like this, just for our connection for our wings, because I know that the wings are next to be connected here. And then, coming down, I'm going to come down a little bit before this angle I have here, because the rest of this section, the rest of this segment is the scutellum. So this little friend right here, that's the scutellum. So it's actually kind of interesting. If you, entomologists have their own words for pretty much everything. They decided that insects are different enough that they can just make up their own words for all of the small parts. So we have our own words for smooth, we have our own words for rough, we have our own words for fluffy, we have our own words for not fluffy. It gets kind of crazy. In fact, to use a lot of keys, Especially when you're new to insect anatomy and you're learning some of these words, you need to have an entomological dictionary and not Webster's dictionary, because so many of the entomological terms are not in the dictionary. Our friend asked what the scientific word for smooth would be, and I totally walked myself into that hole because I know that I know it, but I'm not sure. Maybe it's glabrous? Glabrous is our word for smooth. So, the scientific, I did remember it. It just took me an extra minute. The, scientific word for smooth is glabrous. And that means without hairs, without punctations, just smooth and shiny. And I believe glabrous is a plant word, too. Yeah, all right, very good, Isaiah. Yeah. And then if you were talking about in insects, they'll have what we call punctations, and those are, it almost looks like somebody took a pin and poked a little holes all over the insect. They're just like little divots in the exoskeleton, and so we call those punctations. And then if you wanted to turn that into an adjective and say that there were many of them, I just had it, and then I started describing it, and the word ran out of my brain. Punctations. Punctate is the word. If there are many, many punctations in the exoskeleton, you can just call it punctate. In botany, we have glandular punctations too, or punctate. There you go. Cool. Rutaceae. Does the citrus family of Rutaceae, do those have punctations? Are those punctate? Like in oranges? Is that what we're talking about? Alrighty. So, we have the head, we have the thorax, we've got the antenna taken care of. We're going to be scooting on down. I do want to look a little bit at the base of the wings. I'm curious if it's going to have any type of features over here to protect all of this muscle happening. It's mostly just where the strongest wing veins connect in. So if we see here, this is where our wing connects to the body. Our first and strongest vein on the wing is called the costa. So that would be this one right here on the outside. And then the next one, that one is close enough that I believe we would call it the subcosta. So you've got the costa here, you've got the subcosta here, and then the rest of the wing veins, they are all kind of radiating from those, unless you're considering there are going to be some anal veins that are at kind of the bases of the wings that do kind of connect all the way back up here. I think I bet you if we lit this fly from the bottom side, we would be able to see the wing venations better. But, alas. Oh, that's good lighting. Microscope, stay there. Okay. So what I was trying to see were twofold. One, I was trying to see what the connection to the, what the wing looked like when it connected to the body. And two, I wanted to see all the way at the end of the wingtip because this is the characteristic for every single horsefly and every single deerfly, because horseflies and deerflies are all in the same family of insects. We call them tabanids or tabanidae, all right? And Tabanus, the genus that we're working in, was the first genus identified in this family, which is why it kind of, it umbrellas up or balloons up the tree from Tabanus to Tabaninae to Tabanidae. Now, ouch. The outside wing venation is going to be super, super strong and super, super dark. So this first vein that comes out from the side, gotta make that one significantly darker, because that is both the edge of the wing and the strongest and largest vein on the insect's wing. So it's important. All right. Now, our subcosta, it's coming down here, and it comes a little bit sooner, and it's going to run very much parallel to this. And the costa's probably not going to go that far. We're gonna pull it in just a little bit. About there. All right. And then our subcosta runs parallel to that, but then is going to kind of fade up and meet this section here. All right. It can be a little bit thinner than your costa, but that's going to be important. Now, you also, and I'm not going to remember, I believe we call it the R5 vein, but I would have to look it up to know it exactly. I'm just going through and giving this just a little bit darker so that we can see these. Okay. All right, so coming down from our subcosta, you can see this vein here comes in and then fades towards the front. Then right about here, this is where this vein turns into a Y. And the Y comes over and it angles all the way to the bottom of the wing. All right, so it goes wee all the way over there to the bottom. And that's what we're going to do. We're going to start right about here, and we're going to angle this vein all the way down here to the bottom of the wing. Now, what we'll notice is that after that vein kind of splits, I tried to move the specimen, there we go. After that vein splits, and it goes up towards the top and down towards the bottom, there are no more wing veins in here. All right, and that's going to be our characteristic. We say that the wing venation kind of encloses the tip of the wings. All right, so it encloses the tip of the wings. The rest of these wing veins in here, they don't matter as much. So I'm just going to give 3 in here, and I'm going to leave them kind of light. because those ones are not as important as these two right here that show you that this is a tabanid. And if you look at the wing venation on any horsefly or on any deerfly, every single one of them will have their wing veins enclosing the wing tip. So there's going to be no veins here at the wing tip, and you'll see a very distinct line on the top and the bottom. That is a characteristic for all of them. I love the characteristics that do all of them. The smell comes from the punctations? That's cool. So are the punctations like scent glands? Is that what they are? Or are they meant to? Is the scent an adaptation to make it smell more inviting to mammals so that we eat them, so that their seeds spread? Is that a thing? Oh, cool. Are the veins structural, or are they something closer to human veins? Good question. So, they are a little bit of both. So, they do have very much structural veins. The costa is a structural vein, and the subcosta, those ones, they need during flight because they're thicker. A lot of their power comes from those veins. And liftoff comes from, like, the strength that they are using on the front wing venations. But the rest of the wing venations are important when the fly is emerging from its pupa. All right, so if you imagine the life cycle of a fly, it starts off as an egg, hatches, it becomes a maggot. Eventually, that maggot is going to eat and grow and eat and grow and eat and grow, and it will create a pupal cell, just like a caterpillar is going to turn into a chrysalis or a cocoon before they turn into a butterfly. So once the horsefly, or once the fly emerges from its pupal cell, it needs to expand or blow up its wings just like a butterfly would. So after it emerges from the pupal cell, its wing veins are important for expanding the wings. So its hemolymph, ooh, I don't know if I've shared that word with you. Hemolymph is insect blood. So the hemolymph, in the very beginning when the fly first emerges, the hemolymph does flow through these veins to help expand the wings, to kind of help blow them up. But then the fly has to dry its wings, and so the blood connection to the wings is completely cut off, and then those veins become more structural, and they dry out, and they don't have hemolymph flowing through them anymore. All right, so just like if you ever saw a butterfly or its wings were kind of wet after it emerged, that's because the hemolymph was still flowing through the wing veins, and they're using that hemolymph to kind of push and blow up those wings, and then they'll sit there and flap them so that they dry out, because once they're dry, then they're safe. So that's why if a fly hurts its wings, it's not going to bleed out. Right? Because it no longer is an open source of their blood. You're welcome. Hemolymph, and the difference between hemolymph and hemoglobin is also kind of interesting. Hemoglobin, like our blood, does transport oxygen, right? So as we're breathing, the oxygen goes into our lungs. I'm making a decision. I'm going to do the whole wings. As we breathe in, the oxygen goes into our lungs feed that oxygen to our bloodstream, and then the blood carries our oxygen all throughout our body. Whereas insects, they don't breathe directly into their oxygen does not go into their blood source, into their blood. Their oxygen goes into, they breathe through spiracles, which are little holes in the sides of the body. And then those little holes, they lead to, I believe they call them tracheoles. Tracheoles, tracheoles. And those are the little tubes inside of the body that hold the oxygen. And those tracheoles run to every single cell in the insect's body. Can you imagine that? Like, they don't have veins because, they don't have internal veins in their body because they have an open circulatory system. So their blood is just kind of free-flowing in there. And all their organs are just kind of floating inside of their body. So that's what we call an open circulatory system. And they do have a heart, and we call it the aorta, A-O-R-T-A, and it's more like, I think they call it the aortal vein, even. It's more like a vein, one vein than a heart, and it's like a tube with a bunch of little muscles that are like little pumps, and they pump the blood from the back of the body to the front of the body. It's just one long tube that pumps the blood from the back to the front, and that creates the circulation of their blood. All right, so we have both of those veins, we have both of those wings taken care of. We have the veins that are enclosing the wingtip. We're going to zoom in and check out this abdomen and see what's up here. I was considering drawing the abdomen underneath the wings, but I'm having so much fun with the wings. I like them. I think they're kind of pretty, and they're so dark that seeing through them would be kind of difficult. But what we can do is we can zoom in here. And we can see what is up. I wanted to attempt to see if we can see some of the abdominal segments where the wings are covering. Get this. I think this first whole section from here to about here, that's going to be abdominal segment number 1. It breaks off right about here. Then abdominal segment number 2 breaks off about here. And then we're going to be looking at, let's see, bump. There we go. Just trying to count some abdominal segments really quick. I believe we have a total of 8 abdominal segments. 1, 2, 3, 4, 5, 6, 7, 8. The hair is getting in the way of counting, so I'm going to go ahead and count them from the bottom with you. This is going to be 1, 2, 3, 4, 5, 6. And then there are 2 more above this point that we cannot see. So the third segment is right here. So we've got 1. The first segment's a lot longer than I expected it to be. Then 2. And nope, the first one needs to be longer. that's better. 1, 2. And then this is going to be 3. And 4. All right, so we have those 4 segments. This 4th, 3, 4. This 5th segment is the first segment that you can see kind of the bottom edges of the segment. So this is 5, 6, 7, 8. So when we get to 5, this is about where our segmentation is going to be coming in from the wings. And instead of making this very strong angle here, you can see that each one of the segments are they're kind of like little steps. So we're going to come down and then connect them. So that is 5. And then the next one, we're going to do the same thing. We're going to start where this triangle line touches here, and we're going to go down. So that would be that segment 6. And then number 7 is going to be right here. We're going to continue that. So wherever that diagonal line touches, we're going to go down and then continue this. And then we have our final 8th segment. That is this little point at the end. And then we can go back in and erase any of these kind of lighter lines, these guidelines. Cool. So that's going to be the body, the wings, the abdomen, the antenna. To see our legs, we actually have to turn our specimen sideways. He's so Cetos! He's so floofy! My microscope does have, my camera has an auto brightness feature, and so if I try and get more of the, whoa, look at the eye. Okay, that's super cool. I didn't notice that from the top. This fly's eye is more like a dragonfly's eye than I realized. So, dragonflies, they're Omatidia, they're individual lenses. They're each going to have kind of like a different focal point so that they have the ability to see close, they can see far, and all of these types of things. Because they don't have, like, they have different focal points on all of these. Look, so when we were looking earlier, we noticed that the bottom side of the eye had very, very kind of smaller Omatidia, and then the this main area, these were the larger ones. But if you look here, the smaller, more fine Omatidia, they continue along the back of the eye too. Because that's right there is still part of the compound eye. Even though you see the line there, it's just that the individual lenses are more fine there. Cool. So flies can be nearsighted and farsighted at the same time. Ha ha ha. Alright, let's see if I can get that lighting back now. Alright, so from here, we can see this segment right here is the femur. It comes up and then it turns around, and this is the tibia, and then this little portion here, those are the tarsal segments. So if we were going to label the insect legs, oops. I know that all of you have probably read this about 1 million times now, but hey, repetition is good for us. We've got femur and tibia and tarsi, and so those are our 3 segments to our legs. 1, 2, and then the tarsi, there's normally more than one tarsal segment. In fact, tarsal segments can be identifying features to families in beetles. In flies, I'm not sure if we use the tarsal formulas as regularly as we use them in other orders. But it looks like our tarsi has 1, 2, 3, 4, approximately 5 tarsal segments. Let me go ahead and do the zoom. Yep, 5 tarsal segments. That's a better view of the leg. So the femur is coming up this way, the tibia is coming down this way, and then I will go ahead and just put the focus on the tarsal segments. Because the femur and the tibia, they are mostly just long, thin leg segments. We've seen that a bunch. The tarsal segments are 1, 2, 3, 4, 5. Alright, so starting from up here in the front, let's see. I like to give myself little stick figure legs first, just to see how they're going to look. You want to make sure they're 3 segmented, so the femur that comes out, the tibia that comes back towards the body, and the tarsi that go up. And I try to make the angles so that they don't go into the words. I think that's going to be about right. So our femur starts right here at the pronotum, that first section of the thorax, and it's long and thin. Comes out of the body like this. Our tibia is going to be the one that comes back towards the head. Like that. And then our tarsal segments continue forward from here. And so we have 5 tarsal segments. The first one is about 3 times the length as all of the other ones. So if we do the first one about this length, 1, then all of the other ones have to be about the third of that. 1, 2, 3, 4. And then the 5th segment is generally going to be... The 5th segment is generally going to be rounded out like this. And then with 2 little claws at the end. Tarsi. Alright, so we've got our first leg taken care of. The middle legs and the hind legs are both going to be going backwards. And the legs are so thin in comparison to the body. I feel like maybe I want my legs to be a little wider. But when I look at the legs for this insect, for this fly, its legs, they aren't very wide. They don't have super strong looking legs. But I mean, their wings are incredible. So it's a fly. It used its adaptation points in different places. I laugh about that with my students because sometimes we'll talk about how, you know, insects, oh, our leg is going in the wrong direction when I pinned it. So I like to use, when I'm talking about adaptation points, I talk about scorpions rather than insects because students recognize the fact that scorpions have both claws and stingers, right? So they have 2 defensive mechanisms, and their claws can be super, super powerful. They can be really strong, but if their claws are really strong, then they don't have strong venom, right? They used all their adaptation points already, all on their claws. That's what we say. But if a scorpion has little itty bitty tiny claws and they don't have the ability to hold on to their food, they're actually more dangerous because their venom is going to be even more powerful. Scorpions with smaller claws have stronger venom. And so you could almost say that this fly used all of its adaptation points on having big, strong, powerful wings so it can fly around. And the legs, they're kind of thin. They're just little walking legs so that he can stand, right? It's going to hold his body weight, but it's not like they're super special and he's going to be able to jump or dig or anything or grab anything too powerfully with these legs. All right. Our middle leg is going to be, you can kind of see it here. The wing connection is about here. And so our middle leg is going to be coming out just a little bit behind where the wings are. And because our specimen has wings on both sides of his body, I drew both of the wings. I thought I would kind of cheat for, there's my eraser. I thought that I would kind of cheat for the middle and the hind legs. So our middle legs are going to be coming out right about here. And I'm going to bring our femur out, and then I'm going to bring the tibia right back in, kind of underneath the wings. Because admittedly, that's how they're going to look like from the top. A lot of times you're not going to see them splayed out their legs like this when they're just walking around or when they're at a resting stage. So I'm just going to take our femur and pull it out a little bit behind the wing, and then the tibia is going to come back towards the body, and it tucks underneath the wing, and it just disappears. And we can do the same thing with the hind leg too. The hind leg is going to be connected right about here, but we're going to move our specimen so you can see. I believe that the hind leg is longer than the middle legs. Yes, look at this. All right, so our hind leg is still hidden underneath the wings, but you can see from this angle that the hind leg is significantly longer than the middle and the front leg. So if I was saying that the leg connects about here, it's going to have to be pretty long to be seen. I'm going to take my ruler and go where it should where it should start, and then make my line straight. All right, so we have that femur that's coming out. I'm not happy with where it's coming out. leg. I tried to make it so that it was coming out, and then I was having a hard time imagining it underneath the wing. So what I did is I just drew the whole thing on top of the wing, and I'm going to erase it now. But this shows that we have the femur coming up the front. We've got the tibia coming back towards the wing. The wing cuts off the tibia. You can see the tibia, if it was to continue, it would continue to be probably right about here. Right about here. And then we've got tarsal segments. That first tarsal segment is decently long. And then that one kind of goes to the edge of my wing, essentially. And then we have 2, 3, 4. So 3 more segments that are kind of cup-like. And then this triangular one with the claws. And so I could, in theory, go ahead and erase this leg that's kind of underneath my wing. Because the wing is so dark, but it does continue. This leg does continue. And we do get to see a little bit of the toes, the tarsal segments. I think for a number of my ink sketches, I'm going to be trying to decide which ones I'm going to be adding the other legs to and which ones I'm going to leave only with half of their legs. Because I think some of them would make good kind of coloring book games where it's like draw the other side of the legs. Make sure your insect stays symmetrical. But then on the other side, I really like having kind of very much complete sketches. I guess it's complete when the artist says that it's complete, huh? I'm just going back in and adding some of these. I'm adding my left legs in now. He's so cool. And we can call him Darth Vader. Alright, so my question to you, ladies and gentlemen, is are there any other places on our insect that you would like to see closer or to see again? Are there areas of the insect that we moved a little too fast and maybe we want to look back for closer details? I just want to make sure that we have everything that we need for our sketches. So just go ahead and go back over, look at your sketch. Let me know if there is anywhere else that you would like to see before we close out today. And while you're letting me know, I'm going to flip our specimen all the way upside down, see if we can see anything from here. I was personally curious if the pad on the bottom, if the sponge-like mouth part had any interesting looking markings from the bottom. So that's what I wanted to look at. Huh. So from the bottom, we can see the actual edge of the compound eye. There it is. This right there, that is the edge of the compound eye. So the rest of this area is areas of the head that it can't see with. Haha. time to. So I just wanted to make sure that we had everything taken care of that we wanted to. So we are all done for today. I'm going to go ahead and you go to the closer. So, thank you so much for hanging out with me today. I teach out school classes. You can subscribe to my channel. That's my little QR code where you can donate to my channel, donate to Insectopia. You help me so much when you donate to my cause, and I can continue to teach, and I can continue to travel, and I can buy collecting gear and pinning materials, and admittedly more notebooks, because I go through these because I'm sketching all the time with you, ladies and gentlemen, now, and I absolutely love it. But I go through these journals like crazy. So thank you so much for sketching with me today. This is my final sketch of my of my black horsefly. I hope that yours also turned out well. I'm pretty excited about it. If you are looking for me on social media and you can't find me, that's because I am at Insectopia 2015, not just at Insectopia. Maybe one day we'll be able to get rid of the numbers, but as it is now, that's where you can find me. I will be live streaming every day of the month. Yay! So, tomorrow at 10 p.m., we are going to be having a meet and greet. I believe we will be meeting a tarantula tomorrow. So we're going to go ahead and we're going to do a live stream where we're not going to be drawing tomorrow. We're going to be meeting my tarantulas. We'll probably hold them a little bit. I'll answer your questions about their defensive mechanisms, about their venoms, about how they move and what they eat and their life cycles and their eggs. We can go over all of those things tomorrow for our Monday meet and greets, and then we will just continue to live stream. We're going to be going back over our pencil drawings, and we're going to be inking them for Invertober, right? I've been adding the K every now and again, because you can say it with the K or without, right? It's Invertober because we're doing insects invertebrates, right? So we will include tarantulas and scorpions in Invertober, and we're going to be doing a lot of inking. So, thank you so much, ladies and gentlemen. I had a wonderful time today. Avea, thank you for interacting, asking all the questions. Catherine, I super appreciate your questions about the wing venations, because that's something I generally don't chat about. So it is super appreciated. I hope you all have a wonderful rest of your week. I will see you tomorrow. Stay buggy.